Have you ever truly paused to consider the sheer audacity and complexity of the built world around us? Every wall that shelters us, every road that connects us, every towering skyscraper piercing the clouds, they don't simply spring into existence. Behind them lies a fascinating, intricate world, meticulously shaped by highly specialized tools and perhaps surprisingly, a unique language that brings these structures to life. Our mission in this deep dive is to pull back the curtain on these unseen architects. We're going to take a comprehensive look at the essential hardware that constructs our world, from the smallest, most unassuming hand tool right up to the most massive pieces of heavy equipment that redefine landscapes. And, in a truly compelling turn, we'll uncover the surprising vernacular terms used on construction sites, particularly drawing from a rich list of Filipino construction terms. Our source material provides a detailed classification and extensive examples of these tools, alongside that incredible treasury of local terms.
What's truly fascinating here is not just the sheer variety of these instruments, but the specific, often complex problems each one is designed to solve. It reflects centuries of relentless innovation in building, from the earliest human attempts to shape the landscape to the monumental projects of today. The evolution of these tools tells a compelling story of increasing efficiency, precision, and, well, raw power. This deep dive will provide you with an invaluable shortcut to being genuinely well-informed about the very foundations of our built environment, offering a unique and deeper lens through which to appreciate the world around you.
Okay, let's unpack this. Our sources lay out a clear framework right from the start, grouping all construction tools and equipment into 4 fundamental categories. It's like getting the master blueprint for understanding any construction site, giving us a robust mental map to navigate the immense array of instruments involved in modern building.
Precisely. Understanding these foundational categories is absolutely crucial because they define not just the scale of work, but also the fundamental principles of operation and the inherent capabilities of each piece of equipment. The first category, representing the very origin of building, is hand tools. These are defined as tools whose power is delivered solely by human force. Think of them as the timeless, direct extensions of human skill, strength, and ingenuity. Despite all the technological advancements we'll discuss, they remain absolutely indispensable for precision work, intricate details, and situations where complex machinery simply isn't feasible, necessary, or precise enough. Their simplicity often belies their critical importance and the centuries of ergonomic refinement embedded in their design.
So powered only by people. Got it. What's next?
Moving up a significant notch, we have power tools. These tools fundamentally shift the paradigm by employing power supplied by forces other than human, such as electricity, pneumatics, that's compressed air, or even internal combustion engines. This is where you see a dramatic jump in efficiency and capability. Power tools introduce mechanization to tasks that would otherwise be incredibly laborious or time-consuming with hand tools alone, allowing for much faster work, greater consistency, and the ability to work with tougher materials. They sort of bridge the gap between purely manual labor and the realm of large-scale machinery.
Okay, so human power, then externally powered tools. What's the third category?
The third category is simply referred to as equipment. Now, this is where we begin to talk about machines that are significantly more substantial and integrated than most power tools. They are typically very large, complex tools and machines specifically designed to do a particular job, often requiring a dedicated operator. While they might not be involved in the large-scale earth-moving associated with the next category, they are essential processors or transporters. Think of them as dedicated stations for specific, crucial processes on a construction site, like mixing concrete or precisely surveying a site. They are built for specific functions that usually involve a scale of work beyond what a portable power tool can achieve, often making critical preparations or managing material flow.
Right, so bigger, more specialized than a power tool, but not necessarily moving mountains yet.
Exactly. That brings us to the fourth category. At the pinnacle of scale, raw power, and impact on the landscape, we have heavy equipment. This term refers to equipment which is truly immense and very powerful. These are the undisputed giants of the construction site, characterized by their overwhelming size, their capacity to exert incredible force, and their transformative role in massive scale operations. We're talking about Earth moving on a grand scale, lifting unbelievably heavy structural components for high-rises, or undertaking extensive road building and infrastructure projects. They are engineered for monumental tasks that demand incredible strength and capacity, fundamentally altering the physical environment.
That's a really clear framework. Hand tools, power tools, equipment, and then heavy equipment. So for you, the listener, who might be curious about how a building actually gets built or how that new highway gets paved, how does understanding this specific classification help someone outside the construction industry? What's the practical takeaway for them?
Well, understanding this classification provides you with an invaluable mental map of any construction project you observe. When you drive by a construction site, instead of just seeing a jumble of machines and activity, you can immediately begin to differentiate the types of tasks being performed based on the tools you observe. You can appreciate the progression from fine detail work, which often still relies on the precision of hand tools, to the massive structural undertakings that require the raw power of heavy equipment. It helps frame the specific roles of each tool within the broader construction process, giving you a far more sophisticated understanding than just seeing a generic construction machine. It turns what might seem like chaos into a logical, categorized progression of highly specialized work, truly demystifying the complex process of building our world.
Okay, that makes a lot of sense. It's like having categories to mentally file things away. So let's dive into the first category. Here's where it gets really interesting, diving into the sheer variety and specific ingenuity of hand tools. Before the roar of engines and the hum of electric motors, there was the whisper of human skill. These tools demonstrate centuries of refined design for very specific purposes, showing how ingenuity was amplified not by horsepower, but by sheer human precision and leverage. Let's start with something as fundamental yet profoundly effective as a pry bar. Our sources tell us it's used to force open boards and forming concrete.
And that's a perfect example of a tool leveraging a simple yet incredibly powerful physical principle: leverage. Often recognized as a crowbar, its design concentrates human force into a small point, multiplying it significantly. This allows it to both deftly break apart structures during demolition, like old formwork, and also precisely adjust or align new components during assembly. Its dual role in both deconstruction and the delicate yet forceful shaping of structures is a testament to its fundamental utility, making it an indispensable item on nearly every construction site, no matter how advanced the other machinery.
Leverage in action. Simple, but effective. Speaking of precision, measuring and layout tools are absolutely foundational. We're talking about the seemingly simple yet utterly crucial folding ruler and tape measure. These are the common tools for measuring shorter and longer distances for boards, pipes, wire, you name it. They're the starting point for accuracy.
Their fundamental importance for accuracy cannot be overstated, really. Every single cut, every single component placement, every structural element relies on precise measurement. Without them, you'd have catastrophic structural inconsistencies and immense material waste. They are the silent guardians of exactness in a trade where tolerances can be incredibly tight. The source also highlights the digital ruler, specifically mentioning its use for measuring relatively long distances, such as those in highway construction. This demonstrates the seamless advancement from purely manual tools to those that offer increased speed and precision over vast distances, where even minor inaccuracies can accumulate into major consequences.
Right, measured twice, cut once, as they say. And then there's the framing square, a layout tool used to measure 90-degree angles at corners and joints. It can also be employed to determine cutting angles on dimension lumber. I imagine that's absolutely critical for structural integrity.
It is, unequivocally. The framing square is absolutely critical for ensuring structural integrity and precise joinery. In construction, 90-degree angles are the very backbone of stability. They define the plumpness of your walls and the levelness of your floors. Without true right angles, structures can lean, twist, suffer from uneven load distribution, and ultimately fail. It's not just about marking, it's about guaranteeing that your corners are perfectly plumb and square, which is absolutely essential for the long-term durability, safety, and aesthetic appeal of any building.
So it's fundamental for making sure things are, well, square. For marking straight lines across longer spans, our sources mention the chalk line or chalk box. It's such a simple concept, but incredibly effective.
It's a deceptively simple yet remarkably effective mechanism. It's a string coated in powdered chalk, wound inside a small box. You pull the string taut between 2 points, perhaps a dozen feet or more apart, then gently snap it, and it leaves a perfectly straight temporary line. Poof! It's a rapid and reliable way to create straight reference lines over long spans, whether you're marking out a foundation, laying out a wall for framing, or preparing a subfloor for tiles. It's a testament to achieving maximum utility from minimal components.
I've seen that done. Just a quick snap and you've got your line. Brilliant. And to make sure everything is perfectly horizontal or vertical, there's the level bar. It's described as a long, straight tool containing one or more vials of liquid used to determine exact horizontal or vertical alignment.
The level bar is another absolutely crucial tool for achieving plumb and level structures. Plumb means perfectly vertical, and level means perfectly horizontal. These are non-negotiable for safety, structural stability, and even aesthetics. Imagine trying to hang a door in a frame that isn't plumb, or setting cabinets on a floor that isn't level lit. It would be impossible to achieve a proper, functional, and visually appealing result. These vials containing a bubble and liquid provide an instantaneous visual indicator of true horizontal or vertical, guiding the builder to perfect alignment.
That little bubble tells you everything. Okay, moving on to hammers. The ubiquitous claw hammer is described as the ordinary hammer used to drive or remove nails. It's probably the most recognized hand tool globally.
The claw hammer is indeed ubiquitous, a symbol of building itself. Its genius lies in its dual function and ergonomic balance. The hardened steel face is designed to efficiently drive nails home with controlled force, while the subtly curved claw on the opposite end multiplies leverage for effortless extraction of nails, even stubborn ones. It's a design so perfectly optimized for its purpose that its core form has remained virtually unchanged for centuries, a true testament to fundamental human engineering.
Can't really improve on perfection, huh? For heavier work, when sheer force is required, there's the sledgehammer, a heavy hammer used to drive stakes into the ground and to break up concrete and stone.
When sheer brute force is the only answer, the sledgehammer steps in. Its immense weight is its primary asset, transforming human effort into devastating kinetic energy. This allows it to generate powerful, concussive blows, making quick work of shattering stubborn concrete, breaking apart thick stone, or driving deep foundations and large stakes into the ground where precision gives way to raw, unadulterated power.
So not subtle.
Not at all, pure impact.
And then the ball peen hammer, which is usually used for metal or sheet metal work, that's quite a specific application compared to the general-purpose claw hammer.
This hammer has a highly specialized use where its distinctive rounded, hardened face is ideal for shaping metal without marring it. Unlike a claw hammer, which might leave indentations, the ball peen allows for riveting, peening, that's hardening surfaces by hammering and delicate forming of metal surfaces. It's indispensable in fabrication, automotive repair, and metalworking trades where precise, non-damaging shaping is required.
Interesting. Different hammers for different folks, or rather materials. When it comes to screwdrivers, we have the familiar standard screwdriver with its flat tip for standard slotted screws, and the Phillips screwdriver with its X-shaped tip for Phillips screws. But then there's the spiral ratchet screwdriver, which relies on a pushing force rather than a twisting force. How does that work?
The spiral ratchet screwdriver is an ingenious bit of mechanical design that translates linear push into incredibly efficient rotational movement. It works by having an internal helical groove that guides a nut, causing the shaft to spin as you push down on the handle. This means you're driving screws with sustained, rapid force simply by pushing, dramatically speeding up repetitive fastening tasks, reducing physical strain, and making it far more efficient than manual twisting, especially for high volumes of screws.
Wow, push to twist, that sounds like a wrist saver.
Definitely. Our sources also mention the Allen screwdriver, more commonly known as a hex key. It's used to drive simple bolts or screws that have internal hexagonal heads. These are incredibly common in prefabricated items, flat-pack furniture, bicycles, and machinery where a secure, tamper-resistant fastening is desired. The hexagonal shape provides excellent torque transfer, preventing slippage.
Ah, yes, the bane of many furniture assembly experiences. Now, handsaws. The source distinguishes between a ripsaw, which has chisel-like teeth designed for ripping or cutting with the grain of wood, and the crosscut saw, used to cut across the wood grain. That distinction must be crucial for a good cut.
That distinction is absolutely vital for efficient and clean cuts, and it's based on the very structure of wood. Cutting with the grain, ripping, is like splitting wood. It requires fewer, larger, chisel-shaped teeth designed to separate the wood fibers along their length. Cutting across the grain, cross-cutting, involves severing thousands of wood fibers, which requires more, finer, knife-like teeth for a smooth, clean finish. Using the wrong saw for the job results in rough cuts, splintering, and immense wasted effort.
So different teeth for different directions. Makes sense.
We also have the back saw, a special type of handsaw distinguished by its reinforced spine along the top edge. This rigid back prevents the blade from bending, ensuring very straight and precise, shallow cuts, which are crucial for fine joinery, trims, and moldings. And finally, the hacksaw, which is specifically designed to cut metals. Its fine, hard, often replaceable teeth are engineered to chew through tougher materials like steel pipes, conduit, or metal sheeting, where a wood saw would simply fail or become dull instantly. It's a testament to material-specific tool design.
Right, you wouldn't want to use your wood saw on metal pipe. Ouch. Onto chisels. We have the wood chisel, used to trim wood and clear away excess material from wood joints, and the cold chisel, used to trim metals. How fundamentally different are these two?
They are fundamentally different, primarily in their material composition and the forces they are designed to withstand. A wood chisel has a razor-sharp, precisely beveled edge designed to slice through wood fibers with minimal effort, allowing for precise shaping, paring, and removal of material from wood joints, ensuring incredibly tight and seamless fits. A cold chisel, however, is much more robust, made of hardened, high-carbon steel. It's designed to withstand the repeated impact of a hammer to cut, shape, or break metal, stone, or even concrete without the tool itself deforming or fracturing. They are similar in concept, removing material, but vastly different in their resilience and the materials they can work with.
Got it. One slices, one smashes, basically. And there's a whole category of specialized hand tools. The nail set, for example, is used to drive finishing nails below the surface of wooden trim or molding. That's all about aesthetics, isn't it?
Absolutely. The nail set is crucial for achieving a clean, flush, and professional finish. After a finishing nail is almost driven into trim or molding, the nail set, a small, hardened punch, allows you to recess the nail head slightly below the surface. This tiny indentation can then be easily filled with wood putty, making the fastener virtually invisible and preventing any snags or protrusions. It's all about meticulous attention to detail and aesthetic perfection.
The little details that make a big difference. Then there's the pipe wrench, used to turn objects like pipes. I've seen those on plumbing trucks.
The pipe wrench is indeed a plumber's quintessential tool. Its distinguishing feature is its adjustable, serrated jaws that are designed to grip circular objects like pipes with a powerful, non-slip hold. Its robust construction allows for immense torque to be applied, which is often necessary to tighten or loosen pipe fittings that can be incredibly stubborn due to rust or over-tightening. It's built for leverage and raw gripping power.
You need that grip for pipes. For masonry, we have the brick trowel, used to place and trim mortar between bricks or concrete blocks.
The brick trowel has a distinctive triangular or pointed shape, specifically designed for scooping up mortar, spreading it evenly across brick surfaces, and then trimming off any excess. Its ergonomic design allows masons to achieve uniform bed joints, horizontal, and head joints, vertical, which are critical for both the structural stability and the neat, consistent appearance of brickwork and concrete block walls.
A very specific shape for a very specific job. To smooth out wet concrete, there's the bull float. That sounds like it covers a lot of ground.
It does. Imagine a very wide, flat tool, often several feet long, attached to a very long handle. The bull float is swept across the surface of freshly poured concrete to eliminate any high and low spots, pushing down larger aggregates and bringing a layer of fine cement paste to the top. This creates a uniform, level, and dense surface, preparing it perfectly for later finishing steps like troweling. It's essential for achieving a high-quality, durable concrete slab.
Smoothing things out on a big scale.
Yeah.
And finally, a blind riveter, used to fasten pieces of sheet metal together. The blind part sounds intriguing.
It's called blind because it allows you to set a rivet when you only have access to one side of the material. A blind riveter works by pulling a central mandrel through a hollow rivet. As the mandrel is pulled, it expands the rivet on the blind side, the side you can't see or reach, to create a secure, permanent mechanical fastening. It's invaluable for applications where access is limited, commonly used in ductwork, light gauge sheet metal fabrication, and even some automotive repairs.
So you don't need to reach around the back. Clever. It's amazing how much specialized design and engineering goes into a tool that just relies on human power and mechanical advantage. And speaking of human connection, let's sprinkle in some of the local lingo for these hand tools from our sources. It's fascinating how language reflects the direct human interaction with these tools.
Absolutely. This shows how a tool's function transcends language barriers, but the local term often reflects the history, culture, and practical daily life of its users. For instance, the pry bar is known as cabra, a strong, evocative word. For measuring tools, the familiar folding ruler and tape measure become metro or metrosan, clearly derived from the Spanish for meter, pointing to historical influences. The more advanced digital ruler laser is then intuitively referred to as digital gnaw laser. The essential framing square is actually called escuela, again a direct echo from Spanish escuela. The level is known by several similar terms, libel, nibel, or libel, all speaking to its purpose of ensuring horizontal or vertical alignment. And the versatile chalk line or chalk box becomes pitik-tik, a word that mimics the very sound of the line snapping.
Pitik, I love that. You can almost hear it.
Right. When it comes to hammers, the general term is martillo, which also applies to the common claw hammer and the ball peen hammer, also clearly influenced by the Spanish martillo. But the heavy-duty sledgehammer has its own distinct, powerful term, mazo. For screwdrivers, the general term is destornillador, and a screw itself is tornillo, both direct linguistic imports. Handsaws are collectively lagari, with the hacksaw specifically being lagari bakal meaning metal, and chisels also have their unique terms. A wood chisel is a payet, while a cold chisel is a cincel, reflecting their different materials and applications.
Maso for a sledgehammer. Sounds right. Sounds heavy.
It does, and for those specialized hand tools, a nail set is precisely called a punso. A pipe wrench is known as a liabi, a term often used for wrenches in general, emphasizing its key function. The brick or masonry trowel is a kutsara, which literally means spoon in Tagalog. A beautiful example of how the local term vividly describes the scooping and spreading motion a mason makes with the tool.
Kutsara, like a spoon for mortar. That's fantastic.
Isn't it? A general trowel or float is a rodilla, and the larger bull float then becomes a mahabang rodilla, meaning long rodilla. A blind riveter is simply a riveter, and the humble but essential shovel is a pala. It's truly fascinating how these terms become embedded in the daily vocabulary of the trade, often influenced by centuries of cultural exchange and practical necessity.
Incredible. It adds such a rich layer. Okay, let's move up the ladder of force now. Let's explore power tools. These are the workhorses that truly transform the speed and scale of construction by bringing external power into the equation, radically changing what's possible on a construction site. Take the power drill, for example. Our sources describe it as used to drill holes in wood, metal, and concrete.
The power drill is incredibly versatile, a truly fundamental tool across nearly all construction trades. Its ability to accommodate a vast array of different drill bits means it can bore holes precisely and efficiently through a wide range of materials, from softwood to tough concrete. This significantly speeds up countless tasks like fastening, wiring, plumbing, and even core sampling. It's the essential tool for creating openings for anything that needs to pass through or be securely attached to a surface, and its impact on productivity is immeasurable.
A must-have for almost any job, then.
Then we have the power screwdriver, or screw gun, used to install and remove screws. I imagine this takes a lot of the manual strain out of fastening. It absolutely does, and it offers significant time saving and consistency, especially for repetitive fastening tasks. Imagine manually driving hundreds, even thousands of screws in a day versus doing it with a power tool. It dramatically reduces physical exertion, ensures screws are driven flush and consistently, and accelerates assembly processes, which is absolutely crucial for efficiency in modern construction, particularly in drywall installation or decking.
Yeah, anyone who's put together furniture knows how tiring manual screw driving can be. When it comes to power saws, there's quite a variety, each with a specific purpose. The radial arm saw, used for cross-cutting wood, consists of a motor-driven saw blade that is hung on an arm over a table. The radial arm saw is renowned for its stationary nature as unparalleled precision, particularly for repetitive crosscuts. The overhead arm allows the blade to be pulled across the material, making it ideal for cutting multiple pieces of lumber to the exact same length quickly and accurately. This is essential for framing components, cabinet parts, and other structural work where consistency is paramount. Its design enables high-volume, precise cuts that are difficult to replicate on other saws. So it's great for making lots of identical cuts quickly. Exactly. The table saw is another workhorse, used for cutting large sheets of wood and wood composites. It consists of a blade mounted on an electric motor beneath a table-like surface. Ah, the classic table saw.
Right. It excels at ripping long, straight cuts on large materials like plywood, MDF, or solid lumber. Its fixed blade, adjustable height, and large, flat table allow for incredible stability and control, ensuring perfectly straight, accurate cuts that would be incredibly difficult to achieve with hand tools or even portable power saws. This makes it indispensable for cabinetry, furniture making, and large-scale sheeting, where material integrity and precision are key.
For more mobile cutting tasks where you need to bring the tool to the material, we have the portable circular saw, used for cutting materials that are difficult to cut with stationary tools.
This is truly a contractor's everyday tool, a ubiquitous sight on any job site. Its mobility and raw power make it incredibly versatile for on-site adjustments, rapid cutting of dimension lumber for framing, or trimming sheet goods directly where they're needed. It brings the efficiency and power of a stationary saw directly to the material, making it ideal for rough cuts, quick adjustments, and cutting sheet material too large for a table saw.
The go-to saw for cutting on the spot.
Pretty much. Then, the power miter saw is described as a circular saw mounted over a small table used to cut various angles in wood. This must be crucial for precise joinery.
For things like corners and trim.
Right, absolutely crucial. The power miter saw is essential for trim work, framing, and any application requiring precise angular cuts, whether it's a standard 45-degree miter for a corner or more complex compound angles for intricate joinery. Its ability to quickly and accurately adjust blade angles ensures tight-fitting joints and professional, aesthetically pleasing finishes for everything from crown molding to door frames. It eliminates the guesswork and tedious manual adjustments of hand miter boxes.
Takes the guesswork out of angles. And for intricate or nonlinear cuts, there's the saber saw, used to cut curves or holes in floors and roofs for pipes. It is a small knife-shaped blade that moves up and down.
The saber saw, also commonly known as a jigsaw, though the source uses saber saw, it's prized for its agility and ability to create nonlinear cuts. Its small, thin, reciprocating blade allows it to cut intricate curves, cut out openings for plumbing or electrical lines, or make plunge cuts in confined spaces where a larger saw simply wouldn't fit. It's the tool for detailed, non-straight cuts where precision and maneuverability are paramount, such as cutting countertop openings or decorative wood elements.
So the tool for cutting shapes, not just straight lines. Now, power hammers. The pneumatic hammer or jackhammer is used to break up concrete or asphalt paving. The sound of these is unmistakable on a construction site.
Indeed, the distinct staccato roar of a jackhammer signals serious demolition. The immense force generated by compressed air in a jackhammer makes incredibly quick work of tough demolition. It translates pneumatic power into rapid, powerful percussive blows, literally shattering concrete, asphalt, and rock into manageable pieces. It's a tool designed for destruction and material breakdown, making tasks that would be impossibly laborious manually significantly faster and more efficient.
Brute force, powered by air.
Pretty much sums it up. Similar but different, the rotary hammer is like an electric drill that operates with both rotating and reciprocating actions and is used to drill holes in concrete. What makes it distinct from a regular hammer drill?
Yeah, I've heard of hammer drills too. What's the difference?
That's a great distinction to make, as they're often confused. Unlike a standard hammer drill that just vibrates, a rotary hammer uses an internal electropneumatic mechanism. Think of it as an electric motor powering a piston that generates compressed air, which in turn delivers a much more powerful, true, percussive blow to the drill bit. This literally shatters concrete, stone, and masonry with each impact while simultaneously rotating the bit. This combined action allows it to penetrate incredibly hard materials with relative ease, making it indispensable for tasks like anchoring large fixtures, installing rebar, or breaking small sections of concrete.
So it's actually hammering and drilling.
No.
Much more powerful for concrete.
Much more powerful, yes. And finally, power nailers and staplers. Nailers or nail guns fasten materials together by shooting nails into the building material. The speed must be incredible.
Another huge time saver, I bet.
The speed and dramatically reduced physical exertion offered by nail guns are truly revolutionary for productivity. What used to take hours of laborious manual hammering can now be done in minutes, literally changing the pace of construction. They come in various power sources, pneumatic, cordless, battery-powered, or even gas-powered, each optimizing for different job site conditions, but all share the common benefit of dramatically increasing productivity and reducing fatigue, especially in framing, sheathing, and decking applications. Our sources also mentioned the powder-actuated stud driver, a kind of nailer that is powered by a small gunpowder charge.
Gunpowder.
Yes, like a firearm cartridge almost. This incredible power source allows it to drive long, specialized pins into incredibly hard substrates like concrete, steel, or thick wood, securely attaching materials where traditional nails simply wouldn't penetrate. And then there are staplers, which are similar to nailers but are loaded with U-shaped staples instead of nails for fastening. These are commonly used for lighter fastening tasks, such as installing insulation, roofing felt, house wrap, or attaching fabric, offering rapid, consistent fastening for thinner materials.
Okay, so nailers for heavier duty, staplers for lighter stuff, and powder actuated for really tough surfaces.
You got it. The evolution from hand tools to power tools represents a massive leap in productivity, safety, and what's fundamentally possible on a construction site. It allows for greater speed, precision in repetitive tasks, and the efficient handling of much harder and denser materials. This mechanization makes large-scale, complex projects far more feasible and economical than they ever would have been with manual labor alone. It's a testament to how external power sources profoundly amplify human capability and ambition in construction.
A real technological revolution on the job site. Now let's graduate to the truly large-scale players, the equipment and heavy equipment that literally define the landscape of major construction projects, shaping mountains, building our infrastructure, and reaching for the sky. Starting with standard equipment, which as we discussed are the dedicated process machines, we have the conveyor, equipment that moves materials other than fluids. It's used for transporting loads and materials within an area.
A conveyor's role is absolutely crucial in streamlining material flow and logistics on a large construction site. Instead of manually moving bulk materials like aggregates, excavated dirt, or debris, conveyors efficiently transport them over distances, even inclines, reducing labor costs, increasing speed, and significantly improving safety by minimizing manual handling. They're often seen as the essential arteries of a large construction site, ensuring a continuous supply or removal of materials.
Like a moving sidewalk for construction materials. For ensuring absolute precision before any groundwork even begins, there's surveying equipment. Our sources mention the transit, used by surveyors to measure horizontal and vertical angles to obtain land elevation. The surveyor's level, used to determine an unidentified elevation from a known one. And the cutting-edge construction laser, which flashes a narrow, accurate beam of light to make a baseline for additional measurements, used as a level or as an alignment tool.
These surveying tools are the silent heroes of any project, ensuring fundamental precision and accuracy before a single foundation is poured or a wall is erected. They're literally mapping the future of a building or infrastructure project, establishing the exact coordinates, elevations, and alignments that every subsequent construction step will rely upon. Any error here, even a minuscule one, can propagate throughout the entire project, leading to costly mistakes and structural issues. Their precision is non-negotiable. They are the initial navigators of the entire build.
So, getting it right from the very start. Critical stuff. Then we have pumps, essential for managing fluids on site. The water pump is used to pump water out of holes in the ground so that construction work can commence. I imagine this is absolutely vital for excavation.
It is absolutely essential for dewatering excavation sites. Construction often involves digging below the water table or encountering unexpected rain. Without effective water pumps, the site would simply fill with water, making work impossible and potentially compromising soil stability. They ensure a dry and stable working environment, allowing other construction activities to proceed safely and efficiently.
Keeping the workspace dry makes sense. And the concrete pump used to move concrete from the concrete mixer to the concrete form. This sounds like a game changer for large pours.
The concrete pump is indeed a massive game changer. It allows for incredibly efficient placement of concrete over distances or heights that would be impractical, if not impossible, with traditional wheelbarrows or buckets. It can push concrete through hoses directly to the pouring location, whether it's a high-rise floor several stories up or a hard-to-reach foundation. This speeds up the pouring process dramatically, reduces labor, and ensures consistent delivery of the concrete mix, critical for structural integrity.
Pumping concrete like water. Almost.
Pretty much. Of course, you can't have concrete without a concrete mixer, also known as a cement mixer. This machine mixes concrete ingredients by means of a rotating drum. Raw materials are introduced into the mixing drum through its open end and discharged by tilting the mixing drum to allow the concrete to pour out.
The classic rotating drum mixer.
That's the one. This machine is absolutely fundamental to any concrete work. It ensures that the cement, aggregate, that's sand and gravel, and water are thoroughly and homogeneously combined to create a consistent, workable concrete mix. The continuous rotation of the drum prevents the materials from setting prematurely and ensures a uniform product that will cure into a strong, durable structure. The tilting mechanism makes efficient and controlled unloading possible directly into a concrete pump or formwork.
Gotta have the right mix. And for joining metal components, there are different types of welding machines. The arc welding machine, used to weld materials by melting portions of the metal, typically with a welding rod.
Arc welding is a foundational process in metal fabrication and structural steelwork. It uses an electric arc to create incredibly intense heat, melting the metal pieces and a filler material, known as the welding rod or electrode, to create a strong, durable metallurgical bond between the parts. Our sources also mention the laser-powered welder, which uses a focused laser beam to heat and melt the metal.
Laser welding, that sounds high-tech.
It represents a significant technological advancement, offering much higher precision and control, often resulting in narrower, deeper welds with minimal heat distortion, making it suitable for more delicate or high-performance applications where extreme accuracy is required. The difference highlights the ongoing innovation in joining technologies from brute force heat to pinpoint precision.
Fascinating. Okay, now for the big leagues. Heavy equipment, the true behemoths of the construction site. As you explained earlier, these aren't just larger versions of regular equipment, but fundamentally different in their purpose of reshaping the land itself. Starting with the bulldozer, described as a tractor with a pushing blade which moves earth and clears land of bushes and trees.
The bulldozer is pure, unadulterated raw power, and it's almost always the first piece of heavy equipment on a large site. It's the primary tool for initial site preparation and clearing, capable of pushing massive amounts of earth, leveling vast tracts of terrain, and efficiently removing obstacles like rocks, bushes, and trees. Its immense weight, low center of gravity, and powerful engine make it indispensable for shaping the ground for any construction project, fundamentally altering the landscape to prepare for what comes next.
The ground shaker, the earth mover.
That's it. And then the iconic cranes, machines that lift large and heavy materials. Our sources detail a few types. The crawler crane, mounted on metal treads, allowing it to move over rough terrain. The truck crane, mounted on a truck frame, enabling it to be driven directly to the site. And the tower crane, or climbing crane, used in the construction of tall buildings because it has a built-in jack that raises the crane from floor to floor as the building grows.
I'm always struck by their seemingly effortless precision in placing those massive beams. How do they achieve that kind of ballet with such incredible weight? Cranes are truly the ballet dancers of heavy equipment, capable of incredible feats of strength and precision on the skyline. It's mesmerizing to watch them place massive steel beams with such apparent ease.
They are indeed engineering marvels. Each type serves a specific need and exhibits incredible control. Crawler cranes, with their wide tracks, offer exceptional stability and mobility on challenging, uneven ground, ideal for large, sprawling sites. Truck cranes provide quick deployment and versatility for various sites, as they can simply drive in. And tower cranes are true wonders of engineering. They literally grow with the building, using a built-in jacking system to raise themselves floor by floor as the skyscraper ascends. This allows materials to be lifted hundreds, even thousands of feet as high-rise buildings take shape. They are the essential vertical transporters of modern construction, making the very concept of high-rise buildings possible through their combination of strength, reach, and precise hydraulic and electronic controls.
Climbing cranes, that's just amazing, building themselves up as they build the building.
It really is something to see. Next, the excavator, a machine used for digging or scooping earth from a place and depositing it in another. Under this, we have the backhoe, used for general digging, usually mounted on either a crawler or truck frame.
A classic digger.
Exactly. The excavator, in its various forms, is the primary earth-moving tool, indispensable for digging trenches, foundations, and moving large volumes of soil. The backhoe is a wonderfully versatile general-purpose digging machine. Its combination of a loader bucket at the front for scooping and backfilling and a backhoe arm at the rear for precision digging and trenching makes it incredibly flexible for a wide range of tasks on smaller to medium sites, from utility work to foundation digging. Our sources also specify the trencher, a special kind of excavator that is purpose-built to dig trenches or long, narrow ditches specifically for pipelines or cables.
So just for digging trenches, nothing else.
Pretty much. This machine is highly specialized for creating precise, consistent, and deep channels for utilities like water, sewer, or communication lines, making it far more efficient than manual digging or even a backhoe for these specific tasks. And the front-end loader, described as a large shoveling machine that can scoop or deposit a large amount of material. These are primarily used for moving bulk materials like dirt, gravel, or sand, often loading them efficiently into dump trucks, making quick work of material handling on-site.
Scooping and loading, got it. Finally, we move to specialized highway construction equipment, truly the backbone of our modern transportation networks. The scraper, a machine that loads, hauls, and dumps soil over medium to long distances.
The scraper is a vital machine for large-scale earth-moving projects, especially for road construction, airport runways, or vast land leveling operations. It has the unique ability to efficiently cut, transport, and then spread material across significant distances, minimizing the need for multiple machines and speeding up grading operations dramatically. It scoops up material, transports it, and then deposits it in a controlled, even layer.
A self-contained earth-moving system.
In a way, yes. Then there's the grader, an earthworking machine that grades or levels the ground. This machine is equipped with a long, adjustable blade, often several feet wide, to create incredibly fine, precise grading. It ensures smooth and even surfaces for roadbeds, building foundations, or crucial drainage slopes. And the compactor or roller, a machine that compacts soil to prepare for road paving. Compaction is absolutely critical for creating a stable, durable foundation. These machines use immense weight, vibration, or impact to densify the soil, preventing settling and ensuring the long-term integrity and longevity of the road or structure built upon it.
Packing it all down tight so it doesn't sink later.
Exactly. And finally, the paver, a machine that places, spreads, and finishes concrete or asphalt paving material. If we connect this to the bigger picture, these specialized machines enable the massive infrastructure projects that quite literally connect our cities, facilitate commerce, and drive our economies. Each piece is a vital link in the chain of modern construction, allowing for the creation of vast networks of roads, bridges, and other public works that are absolutely essential for any functioning society. They embody the scale, ambition, and precision of modern civil engineering.
Wow. It really takes an army of specialized machines to build a highway. Now, for something truly fascinating that adds another layer to our understanding, the specific language used on a construction site. Our sources provide a rich list of Filipino vernacular Tagalog terms, showing how culture and history are woven into the very fabric of building in a unique way.
This raises an important question. Why do these local terms persist and thrive alongside more technical English terms? They often reflect generations of inherited practice, the use of local materials, and deeply embedded historical influences, especially from Spanish, which has heavily influenced Tagalog. Understanding these terms offers a deeper cultural insight into the trade, showing how knowledge and practical application are passed down, adapted, and localized. It's not just about what a tool does, but what it's called in the daily lived experience of a builder, a linguistic echo of a shared heritage.
So it's like a living history within the language of the job site.
Precisely. Let's dive into some of these vernacular Tagalog terms, starting with structural elements to really appreciate their specificity. Post refers to a column. This isn't just a direct translation. It's a foundational word that evokes the vertical support, the very spine of a building. Halage means wall. Again, a core structural element, understood immediately on any site. A gilalan is a girder, the primary horizontal support beam. Suleras are joists, the smaller parallel beams supporting a floor. Sahig or suelo refers to flooring, highlighting both the surface and its support. Cepo is a girt, another horizontal framing member, often used in wall construction. A biga is a beam, a broadly important structural component for load bearing.
Post, halage, biga. These sound like fundamental building blocks.
Yeah, they are. Vernacular translates to bottom chord, specifically referring to the lowest member of a roof truss or frame. Riostra means purlin, the horizontal roof beams that support the roof covering. A cenepa is a fascia board, the decorative trim board along the eaves of a roof. Tubik is siding, external, the outer covering of a wall. Pillaret refers to a stud, vertical, the upright framing members in a wall. Pabalagbag is a stud, horizontal, showcasing the precision needed even for cross-bracing.
Pillaret and pabalagbag. Vertical and horizontal studs. Very specific.
It is. Pasamano means windowsill, directly naming a key window component. Sombrero translates to window head, literally hat or cap, elegantly describing its position.
Sombrero. Like a hat for the window. It's great.
Yeah. Hamba is a window jamb or door jamb, the side posts of an opening. Cinturon refers to a collar plate, literally belt, reinforcing the top of a roof structure. Jardinera means a stringer, open, for stairs with open risers. Madre, de escalera, is a stringer, closed. The main supporting beam for a closed staircase, a term with a clear Spanish root, mother of the stairs. And betang means a tread, as in a stair tread, the part you step on.
It's like peeling back a layer of the blueprint to reveal the linguistic DNA of the structure itself. Imagine hearing post instead of column on a site. It adds a whole new dimension to imagining the work being done, connecting it to a specific place and its history.
It absolutely does. And the list goes on, covering finishing elements, materials, and miscellaneous site terms, revealing the incredible granularity of this construction language, mirroring the intricate details of construction itself. It shows how specialized knowledge organically creates its own rich, specialized vocabulary. For finishing, material, and general site terms, for example, gabe is a handrail guiding your way. Moldura means molding for decorative finishes. Slibe refers to an eave, the overhang of a roof. Balata is a projection, any part that extends outward. Blancas means framework, the skeleton of a structure. Canal can mean both a gutter or a groove, showing versatile application. Alulat is a conductor for directing rainwater. Planchuela is a WI strap, a wrought iron strap for reinforcement. Pierno means bolt, a crucial fastener.
Pierno for bolt. Another Spanish connection, maybe?
Very likely. Plancha is scaffolding, the temporary work platforms. Costurada is a plastered course, a layer of plaster. Palitada means stucco or plaster, the finished coating for walls. Rebocada is a scratch coat, the initial rough layer of plaster. Piqueta refers to pickwork on masonry, a texturing technique. Muñeca is a varnish finish for wood protection and aesthetics. Viento means spacing of gap, highlighting the precision in clearances.
Viento. That must be important for things fitting together right.
Crucial. Larga masa is a concrete slab, rough, indicating an unfinished slab. Assentada means alignment, an absolutely critical term for ensuring straightness and plumbness. A master builder's eye is often described as having good assentada.
Ah, assentada. That sounds like a term of respect for skill.
It often is. Hulog is a plumb line, the physical tool used for that perfect vertical. Baldosa is a cement tile, a common flooring material. Batidora is a door fillet, a small strip to finish a door opening. Haspe refers to good green, desirable wood quality. Plantilla means pattern schedule, indicating a template or plan. Bisagra is a hinge, a universal hardware item. De bandeja is a panel door, describing its construction.
De bandeja, panel, okay.
Escombro means earth fill, material used to fill spaces. Lastillius is masonry fill, material used to fill masonry gaps. Hinan means solder for joining metals. Estaño refers to a nickelite bar, a specific type of soldering material. Suban, or subhal, means to temper metalwork, a process to harden metal. Pie de gallo is a diagonal brace, literally rooster's foot, describing its shape and reinforcing function.
Pie de gallo, rooster's foot. That's very descriptive.
It is. Punzel is a nail setter, previously mentioned as a specialized hand tool. Palea is a wiring knob for electrical work, and Espelon is a cabinet hinge, a specific type of hinge. This comprehensive vocabulary, from large structural members to the tiniest finishing details, underscores the incredible detail and precision required in every facet of construction. It's a linguistic mirror to the complexity of the physical world they're building, reflecting not just the objects, but the actions, the qualities, and the historical layers involved.
What an incredible journey we've taken today. We've traveled from the fundamental classifications of construction tools, hand tools, power tools, equipment, and heavy equipment, to the highly specialized individual instruments within each category. We've seen how each tool is meticulously designed to solve specific problems, enabling tasks from the most delicate, flush-finish work to earth-shaking demolition and the grandest infrastructure building. And in a surprising and culturally rich turn, we delved into the fascinating linguistic dimension of construction, exploring the compelling Filipino vernacular terms that breathe culture and history into the very act of building. This deep dive truly has provided you with a detailed shortcut to understanding the complex, multifaceted world of building.
That's right. Understanding the specific purpose of each tool, from a simple chisel, a pancet, to a massive paver, and even the unique terms used on a job site like assentada, profoundly underscores the immense precision, the intricate skill, and the collaboration required to bring any structure to life. It highlights the countless innovations, both technological and cultural, that have shaped our built environment, making it safe, functional, and, well, beautiful. What's truly fascinating here is that this knowledge isn't just for builders or engineers. It's for anyone who lives in a house, drives on a road, or works in an office. It deepens your appreciation for the built world around you, revealing the hidden layers of human ingenuity, effort, and cultural heritage that go into even the most commonplace structures. It's a testament to human problem solving and our relentless drive to shape our surroundings for comfort, connection, and progress.
So the next time you see a building under construction, or even just look at the floor beneath your feet, consider not just the finished product, but the countless unseen tools that touched it. The martillos, the escualas, the lagares. Consider the precise techniques employed, the asentadas sought, and the rich, diverse languages like those Tagalog terms post, halage, kutsara that were spoken to create it. What hidden stories of human ingenuity are embedded in the very foundations of your world?